Okay, so I thought let's have a close-up one this time. And this time we're trying to solve this without using the table problem, using the formulas directly. So what is y bar going to be? We know that's the sum of a y's over the sum of a. So what have we got here? We've got two sections that are the same, 1, 2, and 3. So we can take the bottom section and actually, no, we're not going to take the bottom section, multiply by 2. Right, we will work out what that is, first of all. So we are going to have 120, it's the width, times 30, times the height. The first height is 15 millimeters. Next one, we got 100 times 40. And what's the height of this? Well, that's 30 plus 20 is going to be 50. Next one, area will be the same, so plus 120 times 30 times by this height. So we got 40, 70 plus half of that. So you got 70 plus 15, and we're at 85. Now, with this one, you can just look at your numbers above and just remember not to leave the last number, which is your y position. So you got 120 times 30 plus 100 times 40 plus 120 times 30 equals, where's my calculator? So get your calculator, 120 times 30 times 15 plus 100 times 40 times 50 plus 120 times 30 times 85. That's the top row, divided by 120 times 30 plus 100 times 40 plus 120 times 30. Close bracket, and I get that to be 50. And then I go, it's symmetric. Why did I bother working this out? So we got 30 plus 30, 60 plus 40, 100. 100 divided by 2 is 50. Idiot. Right, okay, so we found the y bar. Now let's do the i's. So let's work out the sum of the i's. Sum of i's. So that's going to be the sum of the 12ths BD to the power 3's. So we've got 1/12. So your bottom one is going to be 120 times 30 to the power 3. Actual fact, you've got two of these. So you got another one, 100 times 40 to the power 3, and here's the second one, 120 times 30 to the power 3, close bracket. So that's going to be all my i's summed up. So 120 times 30 to the power 3 plus 100 times 40 to the power 3 plus 120 times 30 to the power 3. Now let's divide that by 12. Press the enter button and you get 1.073, a lot of threes, right to 5 sig fig, so that's 2, 4, 5 times 10 to the 6 millimeters to the power 4. Right, now let's do the sum of the AH squareds. So if this is 50, the middle one is going to have a H of 0. This one from here to here is going to have, that's 15. So 15, and that's 50. So the difference is 35. So H is going to be 35, and you'll find that 35 is also going to be here because it's symmetric. So to go to the middle there, it'd be 35. To go to the middle there, 35. This area is the same as this area, so it just becomes 2 of them. So you've got 2 of them, which are the same, times by the area, which is 120 times by 30, and the H is 35 squared. So what's that? So 2 times 120 times 30 times 35 squared. Press the Enter button, and we get 8.82 times 10 to the 6 millimeters to the power 4, which makes me think I've gone wrong with the previous one, because that's quite a big difference. 120s. Times 30s to the power 3 times 2 of them, plus 100 times 40 to the power 3 divided by 12. Now I got the same answer again. Okay, so the second moment of area, therefore, is going to be I equals the sum of the 1/12 BDs plus the AH squareds. So that's going to be that number and that number combined. And I get 9.8933. I don't want the final answer in millimeters, I want it in meters, so that becomes times 10 to the minus 6 meters to the power 4. Okay.